In the last two videos, we laid the groundwork for hypothesis testing of one population proportion. This last video, we're going to go through a fully worked example without breaking it down so much. So in this example, we have an old Sports Illustrated study, and they found that 78% of NFL retirees were either bankrupt or under financial stress because of joblessness or divorce just within 2 years of their careers ending. So we have this old value, this old number back from 2009, 78% were undergoing these issues. Suppose we check out a more recent study, and their question is to see if the proportion has changed. Maybe things have gotten better, maybe they've gotten worse. They want to see if that proportion has changed from 78%. So they go out and collect some evidence and some data, and they found that 140 out of 200 in their sample were in fact faced with financial ruin. Our question here is to perform a hypothesis test. When you see this, know that you need to work through all 5 steps we outlined before. So it's a big blank page to figure that out to answer their research question. So our first step we need to do is state our hypotheses. And remember, they always come in pairs. So we have our null hypothesis and our alternative hypothesis. Since this question is about proportions, we're going to use the symbol P, not P hat, but P, because we're talking about the entire population. So we want to see if the proportion for the entire population has changed since 2009. So it doesn't say increase or decrease, it says just simply changed. So we're going to use this not equal to symbol to say, is it somehow different? We don't have a specific direction from the old number, that 78% back in 2009. Our null hypothesis should always look just like the alternative, except the symbol in there is going to be an equal to sign. So we're going to start off assuming it's 78%, and then we're going to see if it's in fact changed or different from that. Next step is where we compare our evidence or our data to that initial assumption, and this is our test statistic. And our test statistic looked like that z-score. You will be given formulas on further future exams and quizzes to help you remember this stuff, but our z-score here was checking out how far our data is from the null, and we had to standardize that, divide by the standard error to make it a z-score. So we had that standard error for proportions, and we made a big deal. The proportion we're plugging in here is that assumption under the null. So we know the null hypothesis, our initial assumption, is that it's the same as it was back in 2009, that 78% of NFL players are under stress, financial stress, after just 2 years in retirement. So we've got our P naught here. We're assuming that, and our sample size is 200. Then we just need our evidence or our data to compare to this initial assumption of 78%. So the problem told us 140 out of 200 were under financial ruin. So that's P hat, the proportion from the sample. 140 out of 200, just work that off to the side somewhere, is 70%. So current data, 70%. We're comparing that to the initial assumption of 78%. If you work that out, you should get a negative number. No need to freak out there. I mentioned that could happen. Negative just means that our data is below the assumption. So sure, 70% is below 78%. You have a little intuition for z-scores. This is getting close to that -3 away, so that's pretty small. But let's actually quantify that into a probability in the third step. So our p-value is going to tell us what is the probability, what are the chances of my data being that far away or more extreme. So let's draw our picture here. Centered at 0, put your test statistics. So mine's negative in this case, negative 2.731. 0.1312. And again, my HA is not equal to. So I want to look at both sides. What are the chances of being that far away, either in the less than direction, so all of this stuff, or in the greater than direction? So again, that's because HA was not equal to, still have that showing up here. I want to look at both possibilities, that extreme below or above. So our p-value, we mentioned there's two ways you can find this one, both will get you there. Just choose one of the tails here and then double it. So I'm going to go with the upper tail on this one. Again, drawing the picture will make sure you don't make any mistakes. Normal CDF. The upper tail would be 2.7312 out to positive infinity. And that would give me this piece, but I also need to consider the bottom part because this is a two-sided test. HA is not equal to, so just double that. And when you do, I get 0.0063. Okay, so this is a probability, and it's the probability of my data, that 70%, being that far away from the assumption of 78%. So chances of being that far off, either above or below. And that's a pretty small probability, so let's interpret that so we have some kind of intuition here. So step 4 is our interpretation of the p-value. And I'm just going to write a reminder here. This is always in terms of the null hypothesis. Get used to that idea. So interpreting this p-value, the p-value used the z-score. The z-score, we plugged in the null of 78 everywhere, so that was our initial assumption. So if the null is true, or in other words, if 78% are bankrupt, I'm just going to write an abbreviated version of that. So after 2 years of retirement, 78% of NFL players are bankrupt. We would see data like ours. Okay, that's our test statistic here. Or more extreme, that's the two sides we shaded according to HA. So I'll say or more extreme. And then the p-value is telling us that probability. Let's write that as a percentage. So just multiply by 100. So multiplying that by 100, you get 0.63% of the time. Okay, so again, the idea is if our initial assumption of 78% is true, we have fairly low chances of collecting this kind of evidence or this kind of data. So step 5 is bringing it back full circle and saying what that means in terms of our conclusion. And as a reminder, our conclusion, we're going to write that in terms of HA, our research claim. So our research claim was that the proportion has in fact changed. So if you need a reminder, refer to this little section, Guidelines for Stating Your Conclusion. We're again in this example on this bottom section. Our p-value is really small. We had 0.6% of the time, which is less than 1%. So seeing our data under that assumption is really rare. So we have really strong evidence that it was a bad assumption, and we're going to go with our research question. So there's very strong evidence for HA. And remember, HA is the proportion is changed from 78%. So I'll say there is very strong evidence that, again, there's very strong evidence because their p-value was so tiny, and very strong evidence for HA in context of our problem. HA is the proportion is changed, or it's not 0.78. So there's very strong evidence that the proportion has changed. Okay, you could word that lots of different ways. So kind of wrapping this all up and thinking what it means in terms of confidence intervals. I mentioned at the beginning of this series of videos that hypothesis tests and confidence intervals are two different approaches, but they're going to agree with each other. So the question is here, based on that conclusion, is my confidence interval going to contain 0.78? So saying the proportion has changed means the proportion has changed from 78%, or it's not 78%. We said there's very strong evidence that it's not 78%. So when we construct our confidence interval, it's not going to contain 78% because we have strong evidence that it's not that number. Okay, so I'll say no because we have very strong evidence, that's our conclusion, for our alternative hypothesis that P is not 0.78. So again, 0.78 should not be in the interval. All right, this concludes our series on hypothesis testing for one proportion. I know it's a whole lot of steps, but the more we do these steps in different contexts, like means and two proportions, they'll start to become more comfortable. But the only way to get comfortable for now is practice, practice, practice.